lesson, I want to show you how to use Blockfrost to make a basic blockchain query. And to build this lesson, let's go back to what we were just looking at in lesson 100.4. In lesson 100.4, like we just saw, people had the chance to mint a PPBL 2024 token. And actually, there's already a list of some of these tokens right here. But let me change examples. Down at the bottom, right? Once again, I'm at Plutus PBL Live Examples. And at the bottom of this page, there are examples for several different modules in the course. And I'd like to look at the examples for module 204. The first example that goes with this lesson, 204.1, is the Blockfrost example. And there's a button right here. And this is very simple. When I press this button, a query is going to happen. Let's just start by looking at the results. Watch this. I press the button, a query happens, and oh my gosh, here's a list of all of the PPBL 2024 tokens that have been minted. Cool. Now, hopefully you notice something fishy going on. It looks like there are 2 tokens for every name. One of them starts with the number 100 and one of them starts with 222. And we're going to talk more about that in the very next lesson. But for now, right, we're going to talk about that in the next lesson. For now, let's just take a look at the example code. There's a few different ways to access the example code for this demo. One way is right here on the page. Right, you can just scroll through the lesson and take a look at the code, but this code is also available in this open GitHub repo, the PPBL 2024 repo, which is the source code for this website, plutuspbl.io. Has an example right here. It's in the source directory, in the components directory, where we have this queries subfolder. And then inside of queries, we have some examples of Blockfrost queries and of Maestro queries. And for now, we're starting with this Blockfrost query. And the code that's on my screen right here is the same as the code that's embedded in the lesson right here. There's just a few extra comments in this version. So let's just go through this piece by piece. In this initial example, we're using a library called Axios. And if you've never heard of it, there's a link underneath the code example where you can read about Axios. This is a library for making promise-based queries in the web browser. Axios is a very, very popular library for everyone building applications in JavaScript and TypeScript. And so what we're showing you here is just a basic example of how to use it. I import Axios. I then create an Axios instance. I can call it whatever I want, right? In this case, I'm going to call it Blockfrost, but I could call it, a lot of times in code, you'll see that people just call their Axios instance Axios, because that makes sense. But it's really important to recognize this name is just arbitrary. I can call it whatever I want. So I'm going to call my Axios instance Blockfrost. And when I create it, I have to add a header with my Blockfrost project ID. This project ID is saved as an environment variable in my project. And there's some notes about this down below. Let's skip to these notes, and then we'll go back to the example. If you've never used environment variables, you can look at an example in the repo. There's a .env.example file right here in the Plutus PBL 2024 front end. And this example shows that there are two keys you're going to have to use. You need a Maestro API key for the Maestro example to work, and you need a Blockfrost project ID for the Blockfrost example to work. And if you make a copy of this file with just the name .env, okay, just this part, you can create your own copy of this file, and then you can add your own API key and project ID. When you do, you will be able to run these queries locally. But without these keys, this app will not work on your computer. So I hope that part makes sense. Does anybody have any questions about what I'm showing you just at a high level about setting environment variables? Okay, this is a great thing to learn how to do. And I know that using kind of, setting up your own environment variables is often one of those hurdles that new devs have to jump through for the first time. Once you do it, you'll start to see that it makes a lot of sense. Okay, and if you've never done this before, I would love to help with this. And there's some other people on the Gimbalabs team who can help as well. So be sure to ask questions. Now, why doesn't my .env file show up in the Git repo? Okay, here's why. In the git ignore file, .git ignore, this shows us all of the files that we are not going to include in our Git repo. And you can see one of the files that does not get included is .env. So let me show you what this repo looks like in my VS Code. Here's VS Code. Nope. There's my browser again. Give me one more chance to do that. There it is. Okay. So here's this repo in VS Code. And you can see right here that I do have a .env file. I'm not going to show it to you because then there would be some private data published on YouTube. But in this file, I've made a copy of these two lines, and once again, I've just replaced it with my own keys. So hopefully that makes some sense how this works. Once I do this, let's go back and look at that Blockfrost query again. We can look at it from VS Code or the browser. I pull it in with this line right here. Okay, so process. This is built into how a Node.js project works. Okay, I can say process.env, and now my Node application knows that I'm pulling in a variable from my env file. And then I have a variable named this, right? We just saw it right here. Next, public Blockfrost preprod project ID. It's exactly what I see here. Now, why do I have this next public part on it? As you might be aware, the application we're building right here, this PPBL 2024 front end, is a Next.js application. And it's not exactly best practice to use Next public environment variables, but I'm using them here just so you can get started quickly with prototyping and learning how to build a Cardano application. This is fine for the learning part of your journey, but when you're ready to go into production, I definitely recommend reading more about how environment variables work in Next.js. And that's why we're including this link right at the bottom of the lesson. You can learn more, right? And you can see right here, bundle environment variables for the browser by prefixing with Next public. That's where that's coming from. However, there are some risks to using this in terms of how your private API keys can be exposed to people who know what they're doing. Now, in the case of, my free tier, um, in this case, right, I have my own Blockfrost project ID. But the worst thing that could happen if somebody got my project ID is they would be able to just use all my free Blockfrost credits, right? I'm not too worried about somebody getting this. However, if I was paying a lot for a subscription and really wanted to make sure that I had a fully secure application, I would not use this approach. I would make sure to get rid of the next public part, and I would make sure to do a much better job obscuring my paid API key. Does anybody have any questions about that part? Sarah, what do you think? Oh, and if you're talking, you're muted.
Sorry about that. So when I moved my app from local development platform to Vercel, the Blockfrost API key and other API key just was not working. I was getting all strings because I found out there's something called CORS, cross origin resource sharing.
Yes.
So yeah, so Nelson helped me out with that. So he sent me some useful links, and it was so maybe you can touch on that a little bit more. Thank you.
That's a really, really important concept. And what I'm trying to do in this lesson is give people just enough to get to the real goal, which is making our first Blockfrost query. So I'm not going to take a detour into the details of how Vercel handles cores right now because it would probably take up the rest of our time today. Okay. But for now, you're exactly right. When it comes time to deploy your application on a service like Vercel, number one, you'll have to learn how to add those environment variables to the deployment. And there's documentation about that. And then depending on your use case and how your example works, you might have to set up some other variables so that your application can interact with some other API endpoints that you need it to interact with. That's always going to be a concern. And I'm really glad you're learning how to use Vercel and cores. But let's save that deeper concept for when we have a little bit more time. Is that okay?
Perfect.
All right. For now, I've already spent, I know I had to spend a lot of time just showing you the basics here of environment variables, but this is kind of giving you just enough so that you can start using things like Blockfrost or Maestro in your own applications, and you can get it working locally. Let's look at a few other things in this example code. Right here, I actually need to define two types because this is a TypeScript file. And you might have noticed that in the repo, all of my component files end with this .tsx extension. If you've ever used React before, maybe you are familiar with .jsx extensions. What's the difference between JSX and TSX? Well, the J stands for JavaScript, where the T stands for TypeScript. And you have both options, but we are using TypeScript. And the reason we're using TypeScript is that it's a bit more reliable than using just plain old JavaScript. Using TypeScript takes a little bit more work initially because you have to make sure that all of your types are compatible throughout your application. When you use JavaScript, you don't have to worry about this. And that's why early on, JavaScript development moves, it feels like it moves faster than TypeScript development. The problem is when a bug emerges in your JavaScript application, sometimes it can be really hard to find that bug. And so even though we're spending a little bit more time up front by making sure that this is actually a fully compliant TypeScript component, we're saving ourselves time in the future because TypeScript makes it a lot easier to find and fix bugs in your application. And that's why right here, I define a couple of types. I need to define an asset type to represent the data that I'm going to pull in from my query. This query is going to give me a list of assets that have an asset string and a quantity string. I'm going to save them when I call set data down here, set data res.data. The result of this API call is going to have a data field in it with a list of assets. I make this response type so that I can have a compliant call right here to the endpoint itself. And this endpoint is going to return some data and a status code. It actually also returns some other helpful stuff, like a cursor, for example, just in case you have a large data set, right? But for now, here's a really nice thing about TypeScript. When I define a type, I'm able to create a type where I don't necessarily have to cover everything, but I can just define the parts of that type that I'm going to be using. Now, another reason I'm showing this to you right now, but not going fully deep into it, is that in the rest of the examples, we're not going to need this part anymore. And I'll show you why we don't need it in just a moment. But for this basic example, where I'm using plain old Axios all by itself, and I'm making this query and saving the data, I needed to create these types to have a compliant TypeScript component. All of my API call is in a use effect hook. A use effect hook allows me to build logic that will run in the user's browser, but maybe not right away, or maybe after something happens. So let's look at the structure of this use effect hook for just a second. What you can see right here is that this use effect hook is going to run every time the value of toggle fetch data changes. The way use effect works is when you load up a web page for the first time, the use effect hook will run for the first time. Then it will run again anytime the variables in this dependency list change. And if you've ever seen the code for like an advanced React application, you might be aware that there can be several different items in this list. For now, I just have one, toggle fetch data. What is toggle fetch data? It's defined up here. It's a use state hook that's just a Boolean. It can be true or false. And when the page loads, its initial value is false. Okay, that's very nice. So the first time the page loads, we try to run this hook. We define an asynchronous function right here, but then we say, hey, if toggle fetch data, in other words, if toggle fetch data is true, then run fetch data, run this async function that actually has the query. But if you're really thinking about this, you notice something important. When the page first loads, this is false. So the first time useEffect runs, toggle fetch data is false, and therefore this if statement does not fire, and therefore fetch data does not run. And that's a good thing. I don't want to run this query every time somebody loads this page. I only want to run it after something else happens. Well, what's the something else that's going to happen? In this case, it's just the user presses the button. Look, I just reloaded the page. When the page loads, no data. But when I press the button, data. There it is. How does that work? Well, like you just saw, we need toggle fetch data to have its value changed for this useEffect hook to run. And then we need that value to be true in order for us to actually fetch the data. So look down here. The component itself is very simple. It's only this is 10 lines of code, right? And 2 of them are just to wrap this thing in a div. Here's an H2. It says, here's an example of querying by policy ID. Let's just situate ourselves. That's this little headline right here. Here's an example of querying by policy ID. Then we have a button, and maybe we see a list of data. The button is right here. Button. Fetch a list of all PPBL 2024 token names. And what happens when this button is clicked? That's what onClick is for. Whenever this button is clicked, we're going to set toggle fetch data, right? Change the value of toggle fetch data from false to true. When I click the button, this value becomes true, which means the useEffect hook fires because toggle fetch data has changed. And then it gets to this. Oh, wait, toggle fetch data is true now. Great. That means fetch the data. How does that feel? I'm going a little bit deeper into just some basics of building a UI with React. And I know that some people are already familiar with this, but if you're seeing this for the first time, do you have any questions to connect the dots here? Okay, so I click the button. Now it says true. Yes, let's fetch the data. So we do this, and then we set the data. Now look at this line right here. We have a use state hook called data, and its initial value is undefined. Undefined plays a similar role to false. And so if you've ever heard somebody say the word truthy or like truthiness, I'm going to write that word in the chat. Truthiness, kind of a funny word. Truthiness. Okay. The truthiness of a value depends on what data type you're looking at. So obviously for a Boolean, true is true and false is false. That one's easy. But for other stuff like numbers or strings or open-ended types like this one, undefined has a truth value of false. And hopefully that makes sense to you, right? If a value is undefined and I ask you, hey, is there any data, right? Data, question mark. We're saying, hey, is there any data here? This is going to be false if it's undefined, if we just loaded the page. And this is why when I first load this page right here, no data shows up, right? There is no data to show because we haven't run the query yet. So this question mark says, hey, if there is data, map over it. Map just means take a list and do a thing for every item in that list. Okay, great. Let's take our data, which we already know has the type asset type list, right? So we're mapping over a list of these things, these asset types that have an asset string and an asset quantity. So we say, okay, map over all of those. And we know that they have a type that includes an asset. So that's what we use. We say, okay, for each item in the list, look at the asset and do this. First, take the substring of that asset. And you can look this up on like Mozilla Docs, for example. Substring 56, what does it do? It just removes the first 56 characters in a string and returns the rest of the string. Why can I remove 56 characters? The reason is because the first 56 characters in an asset string are the policy ID of the token. It's actually this policy ID right here that's in my query. But I don't really care about that policy. I already know that my whole query is about getting all of the assets that have this policy ID. So in other words, these first 56 characters are going to be the same for all of these strings. Let me ignore them. How? By taking substring 56. Ignore the first 56 characters because I already know that's the policy ID. What I'm interested in is the name of each of these assets. Once I have that, the rest of that string, I use the mesh hex to string function to convert it from a hex string to the human readable strings you can see right here. So we went from an asset, we chopped off the policy ID, and then we converted the asset name into something that humans can read. Maybe some of that makes sense, and maybe not yet. So let me look at this a different way. I'm going to jump back to VS Code for just a moment, and you can do this on your own, and I recommend this. Let me go down here, and you can see line 51 is commented out. I'm going to, whoops, what's the key? There we go. Okay, I'm going to uncomment this line because I want this to show up on the screen. What is this? This says json.stringify. json.stringify, you can read the docs right here on my screen, right? This converts some JSON values into some data that I can actually just print to my screen. Okay, and as you're going to see in just a moment, all I'm doing is I'm taking the raw data of this response up here so that I can look at it. All right, I want to be able to read what's here. The pre-tag, right? This is an HTML tag that allows you to format like a monospaced font, which is kind of what people expect code to look like. So that's really helpful. I'm going to save this now that I've uncommented this file. And then in my terminal, make sure I'm using the right version of Node. And I'm going to run this locally, npm run dev. And now it's running at localhost 3000. Let's jump back and look at what we see on the screen now. You see, it's the same website, but it's my local version. I'm no longer at plutuspbl.io. I'm going to go over to the live examples. I'm going to open up example 204, and then I'm going to run this query again. And when I do, look at all the raw data that shows up. Ah, that's Maybe it's nice to look at, but can you see how this is not as easy to read as this list right here? Because it's the raw results of my query. But just like I showed you, every one of these asset names starts with the same 56 characters. That's the policy ID. There it is. So hopefully you can see why I am cutting off the first 56 characters with substring 56. Then, even after I lop off those characters, the rest of the string isn't really helpful to me. I can't read that. So what do? I run hex to string, and I convert this hex string to the human readable string that looks like this. Does anybody have any questions about that? Okay. It always takes the most time to go through the first example. Let's see. I told you about Axios. We talked a little bit about API keys, and I'm going to leave it to you to learn how to get your own API key. Okay, so the step-by-step instructions are to try to run this locally, just like I showed you right here, where I'm running on localhost 3000. But the thing is, you won't be able to see these query results on your local, when you run this project locally without first getting your own API key and correctly placing it in your .env file. So that's the real task for you as a student right here, is to make sure you understand how to do this. I'm not going to teach you how to make a Blockfrost account because Blockfrost already does this. And I trust you to go read these docs, figure out how to sign up, make a new project, make sure the project is on Cardano pre-prod, and then get your Blockfrost project ID. Okay, so that's the exercise for students. Of course, if you get stuck, let us know. There's a lot of people at Gimbalabs who will be happy to help, but I bet you can figure this one out. Once you have your Blockfrost key, you'll follow through with those steps that I referenced earlier, creating your own .env file and placing your Blockfrost project ID right here. If you are successful, you'll be able to see what I see on this example. You'll see the response. And let me, off screen, I'm just going to get rid of this stringified JSON. Okay, look, so you'll see this, and this is how you'll know if you successfully set up your Blockfrost API key, is that this query will work when you run it locally. We talked about hex to string. That's good. We went through some details about how we're mapping over the data. And then, yeah, using hex to string, substring, etc. I think that's everything.